All right, good afternoon. I suppose I should introduce myself first. I'm not the main show, but I'm John Scott. I'm a professor and chair in political science. And it is my honor, privilege to introduce my friend, former colleague, and former neighbor, James Fowler, for this afternoon's keynote address. James is a professor at UC San Diego, and he's both a professor in the political science department and in the medical genetics division of the School of Medicine. James was here at Davis from 2003 to 2006. And when he finished covering his office door with all the press releases about his work, it was time to move on. James's work lies at the intersection of the natural and the social sciences with a focus on social networks, behavior, evolution, politics, genetics, and big data, hence him being here today. Among other subjects, doing network analysis and such, among other subjects, James has looked at obesity, smoking, twins, and voting. As far as I know, he hasn't indulged in any of those sins except for voting. James has recently named, he's had a number of honors, including recently a fellowship at the Guggenheim. He was named one of the 50 key thinkers, doers, and dreamers, and the most original thinker of the year by McLaughlin Group, and most importantly for all of us, he was on Colbert Report and acquitted himself very well. James is the author with numerous people all the time, but with Nicholas Christakis, his long-term co-author of the book Connected, about social networks of all sorts of things and the ways that we're connected in this world. And that has been translated into 20 languages. James is the author of over 100 articles. Keep in mind he's just been out since 2003, so you can figure out how many years that is. And he's been published in numerous times in Nature, Science, New England Journal of Medicine, the Journal or the Proceedings of the National Academy of Sciences, and occasionally in political science journals as well. I believe that James, our flagship journal of the American Political Science Review, you have one article? That's super. Okay, please join me in welcoming James Fowler.
I didn't know this was going to be a roast. Okay, this has been a great day. I've heard all the talks today, and it's gotten me really energized to share some of the things with you that we've been learning about social networks. And the reason why social networks are so important is because they are fundamentally a methodology that spans many disciplines. And so I was kind of on the edge of my seat during the discussion with all these questions about, well, how do you do multidisciplinary work? And do I need to do a 6-year postdoc? These are things that social network analysts confront because we really don't have a home discipline. We usually are trained in a home discipline, but it's not unusual for many of us to end up collaborating with people in other disciplines and doing work that spans them. Now, as John mentioned, I have a long-term relationship. My work spouse is Nicholas Christakis, and he and I wrote a book on social networks called Connected. And during the time that we were going around and telling people about the book, I would have the typical conversation on the plane where people would say, what do you do? And I say, I study social networks. And so what do you think they thought I studied? Just shout it out. Facebook, that's right. And so I always ended up having a conversation that, yes, Facebook is part of it, but really, we started studying social networks long before Facebook was even an inkling in Mark Zuckerberg's eye. We were interested in this question because we were interested in this, the real world social networks that we've had ever since we were huddled around campfires in the Serengeti. We yearn to connect. It is a fundamental part of our identity as a species. There's no other species other than human beings that spend so much time with other individuals of our species that are not our mates and not our kin. When you look to the social insects, for example, they're all related to one another within a group. Human beings, we don't do that. We interact with strangers. And this was even true in hunter-gatherer societies. New work in hunter-gatherer societies is showing that over half of the connections within these hunter-gatherer bands are to individuals in other bands. So this is really something that we've carried with us for a very long period of time. And this is really something that not only is a part of our identity, it also is something that's allowed us to do things as species have not been able to do. We build great cities. We've conquered the earth, and now we have to figure out what to do with that ability, how to rein it in, and how to be able to live with the earth that we're capable of conquering. And so this is really what I'm talking about, these real-world, face-to-face connections that we have evolved to desire and to construct. And so in order to put you in that frame of mind for what a social network is, I need to ask you some questions about your social network. And you can help me out by actually answering this question for yourself. Who are your friends? I want you actually to make a list of your friends. You can write them down if you want, but most of you don't have paper or pen. So just first name, last name, start making a list of your friends. Now, I'm sure that some of you are sort of thinking, well, now, what do you mean by that? And it's true that whenever we ask people to answer this question in surveys, they also will be similarly puzzled. And so we usually prompt them with 2 additional questions, which I'll give you now, that gives you more of an idea of who it is that I'm talking about. Who do you discuss important matters with? And who do you spend your free time with? Now, you'll notice that not everyone on your list, people that you think of that you have a deep, close social connection with, is going to qualify under both of these categories. You might have coworkers who you count as friends that you don't spend a lot of free time with. You might have someone that you go to the game with, and you really enjoy hanging out with them, but you really don't talk about anything that important. And another thing to point out is that when I mean friend, this is shorthand for a close social contact. And so this could include spouses or family members or army buddies, coworkers, neighbors, you name it, anybody that you think qualifies according to these criteria. So first name, last name, make your personal list. Okay, raise your hand really high if there are more than 100 people on your list. Okay, so this is one of the very fundamental differences between what we see online in social networks and what we see in real-world social networks. When we asked Gallup to send this question out to a representative sample in the United States, the average number of people that people named as friends was 5. Okay, so again, what I'm emphasizing here is that we will talk about Facebook, but Facebook is really only going to be a window into our ability to quantify the extent to which these real-world face-to-face interactions are helping us to change our behavior and helping us to understand how the world works. And these friends, as it turns out, are powerful, extremely powerful in this age of computational social science. I'm going to talk in particular about 4 ways that social scientists are using friends in order to be able to do things that we were not able to do prior to being able to collect all of this data that you guys have heard so much about today during the conference. First of all, friends are data. If I don't know anything about you, but you tell me the name of someone on your list, I can go knock on their door and start asking them questions about the things that they like and the things that they do. And then I can make guesses about what you like and what you do. Now, sometimes you don't like the same things as your friend, but on average, we tend to have friends who are like us. So if your friend likes backpacking, I can do much better than chance if I guess that you like backpacking as well. And if all your friends like backpacking, that's a really strong signal that this is something that you enjoy engaging in as well. And so the number one thing that we can do before we get into all kinds of fancy-schmancy theories about why you and your friend might be similar, is just to use that friend information to fill in the gaps for what we don't know about you. Secondly, friends as motivators. Think about the people on your list. There was probably a time, sometime in your life, when at least one of those people said something to you that changed your life. Or they did something, and in the act of doing it, you saw them do it, and you reflected on your own life, and it changed the way you do things as well. Now that's easy to see because you live your own internal life. But what you should consider is that some of the people on that list also feel the same way about you. There are things that you have done and things that you have said to them that they may not have articulated to you about how you influence them. about an idea that you had that got transmitted to them, about a thing that you do in everyday life that got transmitted to them. You come home and say, I just started jogging and I feel great. And before you know it, 6 months later, your friend is jogging as well. And maybe it's hard to see the cause and effect. But for some of these moments, whenever it's you in your internal life, you know that this one moment for you was very important. And so friends can be motivators. And to the extent that we want to make our world healthier and happier, one of the messages from social network research is that you shouldn't just be targeting individuals, you should be targeting their friends as well. If I want to get you to make a positive change in your life, I'm going to do a much better job if I can get your friends involved in that change than if I try to get you to make that change without them. Third way that friends are powerful is as multipliers. And this is the part of social network analysis that just drove me insane. This is what really made me interested in social networks in the first place, because social networks are magical. The fact that you have, on average, about 5 friends in a population means also that you're connected to a much larger number of people in a short number of steps. Because if each one of the people on your list has 5 friends, and you have 5 friends, that means you have 25 friends of friends, and 125 friends of friends of friends. And so if there's something that you do, if there's some kind of change that you make that has some chance of changing the people that you're connected to, you get 2 kinds of multiplier effects. One is in breadth. All the people that you're connected to potentially have the power to change. And you also have depth. The people that they're connected to also have the power to change. And as a consequence, what we are finding in our research is that in many cases, when you change one person, you're actually changing many more than that one person as the change spreads, ripples throughout these social networks. And then the fourth thing, your friends can tell the future. And this is actually another thing that I just find sort of magical, but as a consequence of the mathematics of social networks, and it's a little bit complicated, so I'll talk a little bit more about it later on. But the gist of the idea is that if you want to know what's going to happen in the future, it's much better to focus on the friends than it is to focus on a specific set of individuals. Okay, so that's what I want to do today, what I want to accomplish. Now, before I get started, I do want to talk a little bit about my work spouse, Nicholas Christakis. This is him right here. We're outside of this very famous study called the FRAMINGHAM Heart Study. This is a study that we worked with early in my career, and we were interested in trying to put together health information and social network information. And what we thought we would need to do was to ask people in this FRAMINGHAM Heart Study to give us their lists. The reason why we wanted to do that is because this is a study that's been going on since the 1940s. They started with about 2/3 of the adults of a small town in Framingham, Massachusetts, about 5,000 people, and had them come in for exams every 2 to 4 years, where a doctor saw them and they took measurements, they had them fill out social questionnaires, and it kept going, and it kept going. We learned about the relationship between smoking and cardiac disease. We learned about the effects of cholesterol, and it kept going, and it kept going. And then they started following the children and their spouses in the early 1970s and had them come in every 2 to 4 years. And then they started following the grandchildren in the early 2000s and kept following them every 2 to 4 years. So it's truly one of the most remarkable studies in the history of mankind. And we thought, this is such a great gold standard repository of data. Why don't we just add social network data to this so that we can try to understand how health behaviors might spread from one person to another? And in the process of talking to the people in the study, we discovered an amazing fact. We discovered that in order to keep people coming back year after year, for which they have an incredible record, arguably the best record of any longitudinal study out there, what they did was that they asked people at each exam to give information about their social networks. Not for the purpose of research, but just so they could find them. You know, you go and you say it's time for your exam, but the phone's off the line and there's no one there. You send a letter and the letter comes back, they're not there anymore. And so you pick up the phone and you call the person's friend. The friend says, oh yeah, they moved to Poughkeepsie. Call them there and voila, you can get them back into the study. That's the reason why they collected the information. And they've been doing this since the early 1970s. So we got really excited. We turned all of that social network information into maps. And we layered it on to all this health information that we had from the Framingham Heart Study. And the very first thing that we looked at was, are there clusters of similar behavior? In other words, can I predict something about one of the members of this study by looking at the friends of one of the study? That's awesome. Thank you. And so we started making maps like this. This was a study of obesity. And here, each circle is a person. Each line is a relationship. So you can imagine your list, you would be one circle, and each one of your friends is a circle sort of in the hub, and there's a bunch of spokes. So you can imagine sort of where you would fit in this overall network. And we put other information in the graph. Like, for example, the lines are different colors according to whether or not people are family members or friends. We also put information in the circles themselves. We made the circles proportional to body mass index. So larger circles are literally larger people. We colored the circles yellow for the people who have a body mass index greater than 30, which is the official definition of obesity. And the very first thing that we saw was that there were clusters. There were clusters of obese people, clusters of normal weight people. And these clusters extended out to 3 degrees of separation. What do I mean by that? I mean, it was not just the case that we could predict your behavior from your friend's behavior, and we could. If your friend is obese, it increases your risk of obesity by about 40%. But we can also do this with the friend's friend. If they're obese, it increases your risk by about 20%. And we could also do this with the friend's friend's friend. If they're obese, it increases your risk of obesity by about 10%. And beyond 3 degrees of separation, we didn't find a relationship. So without knowing anything about you, all you need to do is go and talk to your friend's friend's friend and already know something a little bit about you. And we did this not just for obesity, we did this for smoking. If your friend's friend's friends smoke, you're more likely to smoke. We did this for drinking behavior. If your friend's friend's friends drink heavily, you're more likely to drink heavily. We did this for emotions like happiness. If your friend's friend's friend is happy, you're more likely to be happy. If your friend's friend's friend is lonely, you're more likely to be lonely. And loneliness is interesting because it's an experience of the social network itself. If your friend's friend's friend is depressed, you're more likely to be depressed. At a certain point, people got sick of us doing all these studies. And they said, wait a minute, maybe these Framingham people are weird. And we said, okay, maybe you're right. Maybe if we go and look somewhere else, we're not going to find that these behaviors are associated out to 3 degrees of separation. And so we went to the National Longitudinal Study of Adolescent Health and started to do some replication studies. We replicated the obesity result, we replicated the happiness result, and we also did studies like this one where we looked at marijuana usage and sleep behavior. And as it turns out, the folks who were a little concerned about Framingham were right. If you go to a different network, you get different results. In this case, we did not find a relationship out to 3 degrees of separation. Instead, we found a relationship out to 4 degrees of separation. If you're a member of this study and all I know about you is that your friend's 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 friend does marijuana, I can do better than chance by guessing that you do marijuana as well. And in these adolescent networks, we find that these correlations are actually even stronger than they were in the Framingham Heart Study. So overwhelmingly, the lesson from these studies is that you can use friends as data. And this is exactly what the NSA does. We saw a talk earlier today about metadata. So metadata, part of metadata is who you're connected to or who you share interests with. And you can get information about you that you don't have if you know something about the people that you're connected to. Now, that's not necessarily a good use of data because you could be wrong, and in cases that the NSA has acted on, I'm sure there are situations where they've acted on it with not 100% certainty about you. But they could, for example, reduce the number of people that they have to investigate more thoroughly in order to be able to get better information about who they should be keeping track of. So friends is data, but ideally, we're social scientists. We don't just want to predict, we also want to explain. And so as a result, you have to think about, well, what is it that could drive the similarities between you and your friend? Well, one possibility is it's just a false positive. Okay, it just so happens that you like the Smiths and your friend likes the Smiths. And you didn't become friends at a Smiths concert. You didn't make your friend listen to the Smiths. It just, by chance, you happen to both like this thing. And that could be true for anything that you find in common between you and your friend. You flip a coin 10 times, sometimes you get 10 heads. Sometimes you might find these clusters in networks that are just going to be there by chance. This is actually a pretty easy problem to solve because all you have to do in these networks is just randomly reassign who has which attribute and then see what the correlation is between you and your friend. And you can repeat this process 1,000 times, and then you get this null distribution for how correlated could the network be if this was just due to chance. And then you can see, well, the observed value is way out here, so we're sure that there's something going on. Now, what's going on is a real mystery, and there are a number of things that it could be. 3 of the most important ones are as follows. One is, it could be that you tend to choose friends who are like you. All right, so you seek out people who have your same characteristics. That bird didn't make the other bird look that way. They sat down on the wire and they next to each other because they were of the same type. So economists call this selection effects. Sociologists call this homophily. It's one of my favorite words. It's a word that literally means love of like. And so this is actually one process that's really interesting in human networks, is that we do tend to gravitate towards people who are similar to us. And so it could be that the only thing that we found in these networks is not that behavior spreads, but it's that we tend to choose friends with the same behavior. That's received a lot of attention. What has received less attention is this phenomenon of contextual effects. It could be that McDonald's opens up in the neighborhood, and you start eating Big Macs, and your friend starts eating Big Macs. You don't eat there together. You never talk about it. But because it's in the neighborhood, it affects both of you independently. Your weight will go up together. Now, we can control for this geographically by, for example, mapping all the fast food restaurants in Framingham, which we did. But the problem is that geography is not the only thing that controls context. So we have 100 members of the Framingham Heart Study who live right here in California. And if your buddy in Framingham is watching the Super Bowl the same time you are, you might see an ad and you both pop a bag of Doritos because you just can't resist whatever ad they put on the Super Bowl. And so contextual effects are really hard. And again, that could be something that's driving similarity between you and your friend. Again, if you want to predict the behavior, you don't care. If you want to explain the behavior, you care, because there's very different processes, these two processes. And ultimately, the process that we're most interested in is this process of influence. The idea that one person could change their behavior and then cause the next person to change and the next person to change. So in the case of obesity, for example, I don't mean that fat flies off of you and sticks to your friend. What I mean is that you change your behavior. You start exercising and you lose weight. You start eating more fatty foods and you gain weight. We know from experimental studies that if you sit someone next to a person who's eating more, you're randomly assigned to sit next to that person, you will eat more. And you won't even be aware that that person is doing it. And so we know that some of these things, they transmit in experimental studies. But in the observational studies, it's very hard to take even dynamic longitudinal data and turn it into an inference about influence. And so ultimately, what we'd like to know is, to what extent can friends be motivators? When is it the case that someone on your list actually got you to behave in a different way? Now, we have done some very simple statistical longitudinal models that try to get at this. And some of it has to do with just controlling what you and your friend were like previously. And this is very similar to the idea of, we're going to see whether or not you change and see whether or not your friend changes and see whether or not those two things are correlated with one another. We also introduced some new ways that you can use network data in particular in order to be able to ascertain whether or not there's a causal effect. So for example, we used asymmetry in friendship nominations in order to be able to say something a little bit more about the direction of the flow of these different kinds of behaviors. What do I mean by asymmetry in friendship nominations? I mean a very, very sad thing, which is that someone on your list, if I asked them to give me their list, would forget to name you. Now that's very sad for you, but it's not so bad for researchers who can utilize this now, because you can look to see the pattern. Did your friend change, and then did you change as a consequence? If I name you as a friend and you don't name me back, then I expect that when you change, I'll change in the next period, but not the other way around, on average. Now, sometimes you just forget to name people. Sometimes you'll have a friend that's salient. So just because you didn't name someone doesn't mean that they're not a friend, but on average, they are a weaker friend. And also, we would expect that people who mutually name each other as friends, that those are going to be the strongest relationships. That's where we would find the strongest correlations. And we find all of those things across many of these studies, in addition to using time as a way to get more information about causality in observational networks. We also use the network. Now, that said, It's not a panacea. It's not as good as running a randomized controlled experiment. And so we have really good work by some people like Cosmas Shilizi and Andrew Thomas that generalized the omitted variable bias problem to the problem of missing data in networks. If there is something out there that we didn't include in the model that is weakly correlated with the outcome and also weakly correlated with why you and I become friends, then there's going to be some amount of bias in our estimates. And it could be that something that we think is influence is actually one of those other things. It could be homophily. It could be that you and I are choosing to be friends with one another because we are of a similar type. Now, fortunately, although this is saying that all models are biased, we already know this about observational studies. We know that if you leave a variable out of the model, that your estimate is going to be wrong. So the real question is not, is there bias, but whether or not you're leaving enough out that we have to disbelieve the estimates. And so you have good work by people like Tyler Vanderweel, who has adapted sensitivity analyses from regular omitted variable bias problems to measure how big would the omitted variable have to be in order to make the effect go away, in order for us to conclude that there is no influence in the system, that your friends never changed you. And as it turns out, when he applies this to our studies in Framingham, he finds that the result for obesity is extremely robust, but the results for the emotional study, they're sensitive. And what that means is that the happiness result, for example, that could have something more to do with context, for example, which is reinforced by the fact that we found a correlation between neighbors in that study in a way that we didn't with the behavioral studies, with obesity or drinking or smoking behavior. And so these observational studies, they really open up this question of how much of this is influence, how much of the similarity between you and the people on your list is because you affected them or because they affected you. Now, fortunately, because of computational social science, we have brand new data sets to test a lot of these ideas. And we have massive amounts of data, which is going to be really helpful because even with 5,000 people and 32 years of data in our Framingham study, social network studies, we didn't have enough power really to detect anything other than effects that were really, really large. Now, the problem with going online is that now, instead of having your lists, I have your Facebook friends or your Twitter friends. And that's a very, very different beast. And just to give you an idea of how different they are, this is 105 close friends in a dorm room at Harvard. All right, so you can imagine, where were you in your dorm room? I think I was like, right there. So some people are the life of the party. Some people, they're a little bit more reserved. But this looks very much like what we saw in Framingham. So on average, people had about 5 close social contacts in this dorm. We also happen to have their Facebook data, and this is what their Facebook data looks like. It's a big ball of spaghetti. Everyone is connected to everyone else. In fact, it's probably more informative to find out who's not connected to whom, because that might say something more about the people who dislike each other than about the people who are really close to one another. And so when we first started doing our analyses of this online social network data, we were a little puzzled because we did the same tricks that we did in Framingham, and nothing correlated with anything. There's nothing about you that is like your average Facebook friend. There's just too many of them. And so we realized that what we needed to do is we needed to figure out who amongst your Facebook friends are your best friends in real life. And so we started using information like this, photo tagging. So this is a picture of my friends in my research group and me going to the movie The Social Network. It's posted on Facebook, and we are all tagged in this photo. You can see all our names here. We can make an inference about people who are tagged in the same photo. Or we can make an inference about a person who is tagging another person in a photo. Those are both signs that at a point in time we were in the same physical space. And people do this far fewer times than just make friends on Facebook. So the average person in this study had 150 Facebook friends. The numbers are much higher now. The average person had only 10 photo friends, people that they tagged or who had tagged them in a photo. And when we changed the networks and looked at networks, the very same networks, except looking at the photo friends rather than looking at the Facebook friends, they started looking like this. They were much more manageable. And we started finding correlations. And the correlations that we found, unfortunately, were not necessarily of things that were that important. So for example, this is a map of whether or not you're smiling in your profile picture or not smiling in your profile picture. Nicholas is the grumpy one. Here we found that if I don't know anything about you, but I know that your photo friend's photo friend is smiling in their Facebook photo, I can do better than chance by guessing that you're smiling as well. The smilers, they tend to be connected to one another on Facebook. Obviously not the best measure of happiness in the world. We had 4 very good validated questions in our happiness study in Framingham, but this is a representation of what people are actually doing. There's no Hawthorne effect. They're not aware that someone's asking them about their happiness. Now, they may want to project a happy level, but we're still capturing variation within this population between the people who are least likely to do this and the people who are most likely to do it. We also were able to use the photos to estimate people's body mass index. I was stunned that we could do this, because again, I thought people would sort of hide this, but we had intercodal reliability of about 0.9 with undergraduates who were assigned to look at people's photos and then estimate weight and height. And here we found overweight clusters, so clusters of overweight women and clusters of overweight men that both extended out to 2 degrees of separation. So these were just little toy examples on some data we got early in the days before Facebook really exploded. And in fact, this came via a friend of a friend, Nicholas's connection to Mark Zuckerberg via a mutual acquaintance. And it was at South by Southwest that I was presenting some of these toy results that I met this person. This is Cameron Marlowe. He was apparently giving a talk the same time as me. My talk was, look at this toy Facebook example. Wouldn't it be great if external researchers had access to the full Facebook data set? And he was giving a talk about how he was the head of data science and they were seeking collaborations with external researchers. And so mutual friends introduced the two of us, and we started talking about what we might do. And I said, well, your friend must have said, oh, James, he does all this stuff on social networks and health. Maybe we should do social networks and health. And he said, no, we can't do that. And the reason for that is because at the time, Facebook still struggles with it, but at the time it was really bad. We were struggling with these issues of privacy. And then if you go to Kaiser Permanente or any hospital and you ask them, can I have some of your health data? Like they back away in terror. So this is like crossing 2/3 rails to do both of these things at once. And I said, well, if we're not going to do health, what are we going to do? And he said, well, why don't we do something on politics? And I said, I'm a political scientist. That would be great. And so we did a study on Election Day in the year 2010. How many of you are on Facebook? Raise your hand. Okay, and how many of you might have logged in on Election Day in 2010? Raise your hand. Okay, you were in this study, and I'm happy to talk about ethics in the Q&A. So we showed 61 million people either this message or an altered version of this message or nothing at all. So about 60 million people saw this, where you have a thing saying, today's Election Day. There was a link where you could go and look for your polling place that you could click on, and Facebook recorded who clicked on the link. There was a button you could click on to declare that you voted. If you clicked on that button, then the counter in the upper right, it incremented by 1, and that showed how many people had clicked on the button that day on Facebook to report that they were voting. And if any of your friends had clicked on the button earlier in the day, you saw their faces in the bottom of the message. An alternate version of the message that we sent to 600,000 people did not show the faces of the friends. And then another version of the message, or another 600,000 people saw nothing at all. They saw their regular news feed just like nothing had happened. Now, one of the things that we wanted to do is we wanted to estimate how much the message changed people's behavior. But one of the things that political scientists know is that if you're just measuring whether or not people say they voted, you might be not estimating correctly whether or not people actually voted. In fact, in a recent study of, I think it's 10 different countries, the estimate is that about 20 to 30% of the people who say they voted are actually lying. And we know this because we can compare what you say to official records for where you live. In these countries, whether or not you voted is public record. Not who you voted for, but whether or not you showed up to the polls. And they do this to prevent fraud and also to give politicians lists of people that they can contact for the election. And so in addition to these two measures, we also measured whether or not people actually got off the couch and went to the polls. And we wanted to look not just at whether or not the message directly affected people, we also wanted to know whether or not it influenced their friends. Did the friends of the people who saw the message, were they more likely to vote than the friends of the people who didn't see the message? And since we already knew from our earlier work that your average Facebook friend, there's no correlation between you and them, we thought we're going to need to figure out who the close friends are and look at them. And so we developed a more refined algorithm that included more information than just photo text. It included comments and likes and pokes. You remember poking? And all kinds of things that you can do on Facebook. And what we were able to do is we were able to develop an algorithm which with about 90% accuracy could predict who amongst your Facebook friends is your best friend in real life. And this is done on a study where we had information about both your lists and your Facebook data. Now, that was a nice tuned algorithm. As it turns out, you don't even need to tune the algorithm. All you have to do is just count the number of times you've ever touched this friend on Facebook. Anytime you've ever interacted with them, any kind of quality, you still get 84% accuracy on this. And it's funny because this is counterintuitive to people, because everybody has a friend, that guy who posts all the funny cat videos. Oh, I love that guy. Is he my friend? Oh, no. I would never spend any time with him. He's just a cat photo guy. Well, that's the reason why the algorithm is not 100% effective. It's 84% effective. But we were going to use it to see who amongst your friends is most likely to pay attention to you, most likely to transmit the message, or transmit their behavior as a consequence of seeing the message. So at the end of the day, the results showed that the message did get people to the polls. In fact, we estimate it got an extra 60,000 people to vote. And this is a randomized controlled trial. And so this is probably a pretty good estimate of the actual number of people who were motivated by the message. It's very similar to the methodology that's used by standard get-out-the-vote studies. But even more amazingly, we found that the friends were even more motivated. We estimated that 280,000 of the friends of people who saw the message voted compared to the people who didn't see the message. And so what this means is that we've never estimated that before. We spent, you look at any get-out-the-vote study, you look at any campaign, they're always measuring the direct effect. They're never thinking about how much does this spill over to the friends. This is a 4 to 5 to 1 magnifier. Friends are multipliers. And if you add all that up, you can find that just little tiny changes in how much you get this friendship lever going can account for the full effect that you thought you were getting in the first place. And you might be dramatically underestimating how cost-effective an intervention is if you're not measuring these spillovers, measuring how much these effects can spread from person to person to person. And it's a really nice complement to the observational studies where you're not sure whether or not it's homophily or influence. Here, you can be much more certain that there's some kind of influence effect going on because there's nothing about the treatment that was correlated with any attribute of the original people who saw the message or any attribute of the friends. And so friends can be multipliers. That's the third lesson. The fourth thing I want to talk about is friends as future tellers. And this I find to be the weirdest result of social network studies. This is based on work that I did, again, with my work spouse, Nikos Christakis, where we studied the H1N1 epidemic back in 2009. Now, if you live in a network like this one, where do you want to live? And specifically, let me give you context. Suppose that it's the Middle Ages and it's Europe and the Black Plague is rolling through. Do you want to be a hermit or do you want to be the life of the party? You want to be a hermit, right? The reason why is because you don't know who's going to get it, but if you live in the center, you're going to be a lot closer to whoever got it than if you're a hermit. On average, it takes many, many more steps for the flu to get to you if you're a hermit than if you're right in the center of this network. And a corollary to that is you're going to get it sooner if you live in the center of the network. On average, the people at the center, they're going to get whatever's spreading through it sooner. And that looks like this in a traditional epidemiological model. There's this traditional model where there's this S-shaped curve for how many people have gotten the flu. At first, no one's getting it. It's not really going up very much. But then patient 0 gets it. And then she tells 2 friends. And then she tells 2 friends, and so on and so on and so on. And you get exponential growth. Eventually, people get the flu, and they recover from the disease. They're not going to get it again. There's no one left to infect. And then you get exponential decay in the other direction. For people living at the center of the network, this whole curve is shifted forward in time because they're in smaller number of steps on average from everyone else in the population. So if you want to monitor an epidemic, do you monitor people at random taken from the population, or do you monitor people at the center of the network? That was the question that we were asking. We were also asking the question, could you do this monitoring without having network information? Because a lot of times, we don't know who's connected to who. It would take me a long time to put your lists together and figure out, was the person that you named, the John Smith that you named, also the John Smith that was here today, or the John Smith that someone else named? It's an expensive proposition to put together these real-world networks. And so what we wanted to do is we wanted to think about, well, how could you figure out who are the central people without having network information? Well, you could monitor this network by randomly choosing people. Or what you could do is you could randomly choose some people and ask for their lists. I'm going to take 5 of you in this room. I'm going to ask you for your list. And instead of putting you in my study, I'm going to send you home, and I'm going to put one of your friends in the study. And the reason why I'm going to do this is because your friends are more popular than you are. It's not because you're uniquely unpopular. Don't worry. This is a fundamental aspect of social networks. A person who has 10 friends is going to show up on 10 people's lists. They're going to be overrepresented in the population of people who are on the lists of people's friends. And so as a consequence, what you can do to find central people is you can just go one step away from someone. So now that's a lot less information. And the theory is that those people, because they're more central, they're going to get the flu sooner. And that's exactly what we found. So those individuals get the flu on average about 2 weeks sooner than other people in this particular study of H1N1 at Harvard in 2009. And as it turns out, this works not just for flu, it works for anything that spreads in networks. So for example, tweets, hashtags. Some hashtags go viral. As it turns out, if you use this same method, you go from a randomly chosen person to one of their followers or the followees, it doesn't matter. They tend to be more connected in the network, and as a consequence, they tend to get whatever's going viral sooner. You get this whole curve push it forward, for example, for this hashtag Open Web Awards. And if you watch carefully to see when those two curves diverge, you follow the randomly chosen people and you also follow the friends. When the friends start doing it a lot faster than the randomly chosen people, that's the sign that there is a network process going on. And you can actually use that divergence to get much earlier warning. So for example, we would have been able to predict that Obamacare was a thing about 3 months in advance of its usage peaking on Twitter for the first time, whenever they started calling the American Care Act the Obamacare. And the nice thing about this is that if you can predict the future, you can change the future. Right? So if these guys are helping us to predict where the epidemic is happening and when it's going to happen, you can also find the same people and intervene on them to get a bigger effect in anything where there's a spillover. So for example, we have a paper coming out in the Lancet where we went to villages in Honduras, and some of the villages, we just randomly gave people either a multivitamin intervention or a chlorine intervention. And in other villages, we did exactly the same thing, except instead of going to the randomly chosen person, we went to one of their friends. And in one of these two interventions, I always forget, the multivitamin intervention, we actually got a lot more uptake in the villages where we did the actions on the friends than we did on the strangers. It did not work in the chlorine intervention. We're still investigating why we get differences in those two different situations. But we now have this big Gates project where what we want to do is we want to investigate to what extent is this something that you could apply to a wide variety of different kinds of interventions. Let me just wrap up with some other work that we're doing on Facebook that utilizes some of these 4 different ways that friends are powerful in big data. One of them is on ideology. So you guys saw earlier today this measure of ideology from conservative liberal that Justin Grimmer showed, which is based on roll call voting. It's based on did I vote a lot like a conservative senator, then I'm probably also conservative myself. And you can actually use multi-dimensional scaling methods to align people from left to right using this method in a way that makes a lot of sense. Well, you can do the same thing with individuals on Facebook and their likes. So if you take all the politicians on Facebook and who they've liked, you can use all the co-likes, so all the things that you liked and another friend liked, in order to make an inference about whether you and your friend are in the same location in this liberal conservative space. And when we did this, we were able to get estimates that looked pretty reasonable. So our far left estimates, the people self-reported as their ideology as Obama or Democratic Party or very liberal. And the people who were very conservative, they said they were conservative or Republican Party or Republican. And even better, you can get estimates not just for the people on Facebook, but you can get estimates for the politicians as well. And this is the current sort of gold standard based on roll call votes of politicians. And then this is the Facebook ideology score. You can see there's a lot of similarity between these two indices. And so you can use these likes as data to put people in spaces, in this like space, that's going to tell you potentially something that's very interesting depending on what it is that you're studying and depending on the set of things that you like. We focused on the likes of politicians. You could focus on the likes of food, for example, to study eating behavior potentially. You could also study employment. Okay, so there's a long literature suggesting that people tend to help their friends get jobs, and there's a debate about whether or not people use their strong ties, people on your list, or weak ties, people who aren't on your list. So think about your job. Did you get your job from somebody on your list, or was it somebody off of your list? Well, as it turns out, Mark Granovetter wrote a very influential piece in 1973 pointing out that it was probably someone who wasn't on your list. And he argued the reason why is because the people who aren't on your list, they have better information or new information than the people on your list. You already know everything that the people on your list know. But you don't know the things that the people aren't on your list know because you don't talk to them that much. And so we investigated this on Facebook with millions of people and discovered that actually, while it's true that you're more likely to get a job from a weak tie, from someone that's not on your list, this is not because they have better information. It's because you have more weak ties. You have 700 Facebook friends, you have 5 to 10 people on your list, chances are it's going to be one of those other 690 people that helped you get a job. In fact, the more you increase the strength of the friendship, the more likely someone is to help you. And that overcomes whatever informational benefit there may be. And then the last thing I'll talk about is happiness. So the nice thing about Facebook is that people are using happy words all the time, using unhappy words all the time. I don't like those posts. And what we can do is we can use dictionaries of these positive affect and negative affect words that have been validated and well established over a long period of time to measure total sentiment on Facebook. So this is for 2011, for example, positive words on the left, and you can see, for example, that there's a slow increase. This is probably because Facebook is tweaking its engine and making it more feasible for people to express themselves positively because more people will use it. Meanwhile, negative stayed about the same during this time period. And those aren't scaled the same. They're actually about twice as high on the left. There's more positive language than negative language on Facebook. You can also measure which are the most miserable cities. And you can see there's a lot of misery on the coast because the blue is miserable and the green is happy. You can also map the friendship networks between these different cities to see how much happiness in one city might affect someone in another city. And the reason why we do this is because we want to use a method to be able to infer a causal effect, but without doing it in an experiment. As you guys may have heard this last year, Facebook got into a lot of trouble doing it in an experiment on moods. And this is a way for us to try to estimate a causal effect without doing that. How do we do this? We use rainfall as a random variable in the environment as an instrument to predict how happy your friend is who lives in a different city on a day when it's not raining on you. And if that rainfall makes your friend less happy, and then if the amount that it makes your friend less happy also predicts your unhappiness, that suggests that there's a causal effect of your friend's use of these words influencing the words that you use as well. So in other words, if your friend in New York is raining, if it's raining on your friend in New York, does it make you miserable right here in Davis today? The answer is yes. And we find a direct effect. We find that when it rains on you, you use fewer positive words and more negative words. And your friends who live in cities where it's not raining, they also use fewer positive words and more negative words. And we estimate the multiplier effect again here. And the estimate is that for every happy post on Facebook, it causes another person in your network to make a happy post. And sometimes even 2 of the people in your network to make a happy post as well. So in other words, you get a 2 or 3 for 1 out of the deal every time you express yourself positively or negatively in that context. So that's it. Friends are powerful. And this is a really exciting time. And I really got that excitement from everybody that was talking today, all these presentations about these new data sources and how it's going to change how we see the world. And I completely agree with that. And I would just urge all of you, don't just look at the quantity of data. We lived through the 20th century and had a couple of really important innovations. One was statistics. We got a long way with statistics on an assumption that all the observations are independent. Game theory and microeconomics, we got a long way with modeling human behavior under the assumption that people are rational and self-interested and they only care about their own, what they get, not what anybody else gets. As those different kinds of assumptions are being relaxed, we are coming closer to being able to explain things like altruism and being able to explain things like correlated observations in some of these really sophisticated data sources. Social networks is about assessing the amount of non-independence there is in the world. And it's amazing to me how much of our theory is built not on us thinking the world is independent, but it just being convenient. It's convenient to assume independence because the math is a lot easier in statistics, believe me, and a lot easier in macroeconomics to make that assumption. And it's amazing to me how much people who use these tools will defend the assumption as though that's the reality rather than being the convenience. And so social networks are a way to move past that and for us to be able to explain this interdependency, which I hope you can agree when you think about your own lists, is at the core of our human identity, at the core of what it means to be human. And one of the reasons why I'm so excited about computational social science in the 21st century. Thank you.
Time for Q&A. Questions?
I'll ask one. It sort of came up in the happiness versus unhappiness, but my question was really more like about obesity when you were measuring the effect. Which one is more contagious? So if two of my friends get larger and two of my friends are getting thinner or thinner than me, which one wins? I mean, so which one's more contagious?
That's an excellent question. And I think that in our study, we were underpowered to detect this, but we checked it and we didn't find asymmetries in any of the Framingham studies. The only asymmetry that came close was in the happiness study. And again, bear in mind that we were estimating a causal effect, but maybe it was something else. But we did find in that case that happiness tended to be more strongly correlated than unhappiness. But with obesity, when we looked at, for example, differentially looking at a model that just included your friends who are overweight and a model that just included your friends who are underweight, we didn't find significant differences in the estimate to which you and your friends' behavior was correlated.
Hi. I'm curious that in a social network, if it seems pretty, the trend is pretty strong. That is, if one or a number of your friends are getting bigger or smaller, or and you will more likely to have the same change. But what if someone has a number of friends who change in different directions in a group setting?
Yes.
And what is more?
Yeah, so there's two ways to model this quantitatively that are easy. There's probably more ways than that, but the two main competing ways that you model this are, we're just going to take an average, right? So you may take an average, a percentage of your friends who are obese, who are above the threshold, or an average body mass index for your friends, right? And then we look at and see how the average changes and whether or not that's correlated with your outcome measure. But there are other situations where that might not be appropriate. You only need one friend to convince you to vote, for example. And so it's possible there that what you really need is a threshold model where if at least one of your friends vote, then you're more likely to vote. But then if the second friend votes or the third friend votes, maybe that's not going to have any kind of impact. In practice, we don't typically have a priori hypotheses about which of those it's going to be. And so we let the data speak for itself. Now that's good in that we get information about what the process is likely to be. It's bad in that it introduces another test. And so if you do something like that, you want to be conscious of the fact that the statistical probabilities that you're assigning to the null hypothesis are now going to be off, right? Because you're doing multiple tests in this case. And then usually the best way to deal with that, in my opinion, is just to go do the science again on a different sample with the hypothesis that you got out of the data from this study where you tested multiple different ideas. Yeah.
Thanks, James. So the same way that economists still don't really like thinking that humans use emotions to make decisions, how do you convince folks that using networks analysis is a proper method for investigating complex social behavior because, it's still a relatively new field. And in my research specifically, I've faced some pushback against this. And so just trying to see, when is it appropriate to use this sort of network analysis approach, and how can you justify these approaches to folks who don't buy it necessarily?
Yeah, so our focus is always, the thing that I've always been really interested in is this spillover effect and this action at a distance. Estimating how many people out in the world have changed their behavior because of something that you did. I just find that magical. It's like the science of karma or something like that. I'm not sure how you do that without network analysis. So that question, it specifically lends itself to network analysis. But you can imagine any question, for example, in my home discipline of political science, just about anything that we study is probably going to be susceptible to a certain degree to these network effects. And so there's a couple of things. One is you need data, right? And the other is you need an outcome variable that people care about. And so you look at work like by Mike Ward, for example, where he has looked at these massive data sets of which countries have gone to war with which. And there's all this information about how much money these countries make and how much they trade with each other and whether or not they have alliances. And you can do these models. And for a long time, people did these models using a conventional regression framework. In fact, some of them didn't even control for repeated observations, let alone controlling for the network structure. And what people like Mike Ward find and Zev Maus and other people that have worked on this is that in the network structure itself, you're able to predict things that you weren't able to predict when you didn't account for it. But what's really important here, and I get papers to review like this, you can't just throw this data into a visualization program and make a pretty picture and then say, science. You have to show how what you've done gets us more than we got under the traditional independence-only model. There's a reason we start with the independence-only model. It's because it's easy to understand. We can do asymptotics on the statistics. We can get closed-form solutions with the microeconomic models. It's not a bad thing to start there and say, this is not the way the world works, but this is a base. And now we're going to look at the distance between what that model predicts and what the real world model gets us. And now I'm going to use network theory to show how this bridges the gap. That if you take into account specifically the structure, I'm going to get you closer to what we see in the real world, which means that networks are probably a part of the explanation for human behavior in that particular case.
Thanks, James. This was an exciting talk. I have two questions. Number one, did you look at imbalances? So two friends are enemies, and how that affects behavior. Second question, did you look at spillover between different networks? For example, between obesity and happiness?
Okay, so we don't have enemy data. And as you know, well, you study this a lot, it's very hard to get this data. In our Honduras pilot study for the Gates project we're working on, we tried collecting enemy data, and people are not willing to talk about this. It's really hard to collect, you guys are probably willing to share your list of friends with me, but from that study, I think it was like 20 to 1. We got 20 times more friends. And I'm sure there's a lot more enemies than that. They're underreported. So there's that problem. In terms of looking at overlapping networks in Framingham, we never did that in Framingham. The marijuana and sleep loss study was an attempt to do this. That was probably a miserable failure because that article ended up in PLOS One, and I think it's been cited like twice or 3 times or something like that. So it's complicated, and I don't think that we actually succeeded at making it simple enough to be able to do the analysis across different networks in a multiplex system to be able to get us more information than we would have had by just studying them separately. And this is, if you guys are really interested in networks and you want to make your mark, if you can figure out how to do this, I think there's a lot of real interest in being able to see how people walk different networks. I know that Matt Jackson and Esther Duflo, those guys, they collected a lot of different kinds of network information in some of their work in India, and we've been studying some of those overlapping networks structurally, but we don't have enough behavioral data there to really study how behaviors might jump, say, from one network to another, which I think is a super interesting question.
Hi. So I've come across research like 2 years ago that looked at the Chinese analog of Twitter, which I believe was called Weibo, and they looked at emotional contagion. And they saw that even misinformation can lead to very real and violent consequences in the real world that comes from information or propaganda that is distributed within the social network. And so I ask you, since you invited ethical questions, I ask you as a political scientist, is it worth potentially safeguarding against, well, let me preface this by saying that within the broader social network, there are individuals who may have financial and political power who may actually see this information and see it as an opportunity for disseminating perhaps misinformation or simply inhibiting the transmission of accurate information when it comes to, say, things like you measure like ideology. And so I ask you, like, how can we safeguard against that? I see this work, it's brilliant work, but I also kind of see, like in Batman, when Lucius Fox has the creation he made of being able to contact every single individual in Gotham to find the Joker, but knowing that, he's got to get rid of that after he makes it. It's like, it's like one of those things where it's like, you can do it, but should you do it kind of thing? Because, someone can see this and like I'll stop ranting in a second, but for instance, being able to selectively and preferentially identify these key individuals that are central nodes within the network and being able to make these kind of future-telling predictions about what's to occur. What happens when perhaps accurate information or social movements are starting to spur and cause change, but perhaps individuals who are in power can cut that off at the root and stop real progressive change in favor of political or financial special interests?
Okay, there's a lot there. I'll say I think we're faced with Pandora's box at this point. We're not going to go back to a time when people are not leaking information all over the internet. So I completely agree with Justin Grimmer when he said privacy is dead. It's just gone. And so rather than trying to change whether or not your data is private, I think we should focus on appropriate use of data. And it is inappropriate to kill someone based on a hunch that you got from some algorithm. It may be appropriate to bring them into court and try them for this crime, and you can present to a jury the evidence that you got from social media that suggests that this person did something that they should be convicted for. So I tend to, my problem is I tend to be this way in all of my life. I hate sort of filling out forms. I would rather ask forgiveness than ask permission. And I feel like the system in this case, in this particular case, it actually would work much better if we spent all this energy that we're spending on trying to push data back into its box, and instead setting up rules for what do you do with the data when you get it. If we think it's inappropriate for our intelligence agencies to have this information about everybody in the country, then maybe we should do something about what they're able to do with that information. To say that they shouldn't access it, I think, is maybe a little bit naive because they've been doing this for 30 years. In the very first talk this morning, we saw a slide on crime. So police have been using data to try to figure out who suspects are and where hotspots are for a real long time. And what algorithms do is they help to make that more accurate. But it's not really new. Police want to know where the bad guys are. Police are not allowed to go and kill a bad guy as soon as they find him. They bring that bad guy in and present their evidence that they get from these systems, from other systems, and then put them through this process. So to the extent that we can strengthen the process at the end for how we deal with this data, how it's presented to juries, about to what extent it counts as evidence in trials, for example, I think we're going to be much better off as a society.
Yeah, I wondered how family fit in this and how you put this, because you can imagine family members putting it this sort of model as being a super or a hyper friend, very influential, very positive. If your sister goes on a mass diet, you might do that, things like that. On the other hand, you could see it as a negative, someone around you who dissuades you from doing a certain amount of behavior. I say this is very anecdotal. I was at a funeral last weekend. Sounds like the beginning of a bad joke, but and we talked about sort of who died of drug abuse from my high school class. And there was this incredible argument, and these are people from, there weren't many social scientists represented, who said it all comes down to your mother. The people who, if you had a strong mom, you could have 5 friends who were, bringing pot in, snorting lines in high school, whatever. If mom, and that seemed to work well, and other people said, no, it's personal. The two people the person who we were mourning that day had these tendencies, these sort of things. I just wonder where family in this data fits in.
Yeah, so we were able to compare like spouse ties to friend ties and sibling ties in Framingham. In the National Longitudinal Study of Adolescent Health, we were able to compare siblings and friends, and also look at the connection between parents and you and your friend's parents and you, for example. And parents appear to be influential in that context, right, to the extent that you can claim that in an observational study. But one of the interesting things that we found was that one of the reasons why parents are influential is because of this indirect effect, where your friends' parents will influence your friends, and your friends then influence you. And so when your parents intervene on your network to figure out who you should be friends with, any of you who have kids will know this intuitively. You're not just evaluating the child, you're evaluating the child's parents as well, trying to get all this information. And I don't know how much control we have over this, but in this era, like, we do sort of feel like we have to make these decisions all the time. And so to me, it's intuitive that this would be the case. And in fact, in that study, we found that the friends' parents were actually more influential than the parents themselves. Because adolescence is a period of time where adults are specifically trying to do the opposite of their parents, which probably wipes out what the typical average influence effect would be from parents. In the Framingham Heart study, one interesting thing that we found in the obesity study was that friends were more correlated in their behavior than spouses. And this almost killed the whole research project before it began, because we showed that result to a lot of our colleagues, and they said there's no way that could possibly be true. I cook with my spouse, I live with my spouse, I eat with my spouse. Surely spouses are going to be more correlated than friends. There's something wrong with your data. And so we pushed on this a little bit more, and we went back and looked at the friends, and we parsed them into opposite-sex friends and same-sex friends, and didn't find any relationship between the opposite-sex friends and very strong relationships between same-sex friends. And this was at a time when all the marriages that we have in our data are all opposite sex. And so while spouses are probably the strongest tie on average in our data, they also represent this opposite sex relation where in the friends, there's no evidence that they're influential. Men don't look to women, if that woman lost 5 pounds, I'm going to lose 5 pounds too. It's men looking to other men and women looking to other women in that particular study. And so the lesson we took from that, especially because we didn't get that kind of result in a lot of the other behavioral studies or emotional studies, is that this is very highly contextual. And I think it brings home a point that we've heard over and over again today. You need the qualitative data and the quantitative data. You need to know something about the cultural context to be able to have good theories about why you're going to get variation from one time to another. Even if on average these network effects tend to be strong, they're going to be stronger in some cases than they are in others.
So I was kind of curious about your, I was kind of curious about your political ideology slide, and I was wondering if you found in your research whether the social networks were exacerbating this homophily effect you were looking at, whether people were tending to select people who are ideologically similar to them as a result of being in these social networks, and additionally whether the social networks themselves were creating ideological polarization that was observable in your data.
When is this video going online?
When's it going online?
Yeah.
Next week.
Next week? Yeah. Okay, so there's an article coming out in Science that addresses this next week. I would feel bad about saying anything about it now because it's under embargo, but it addresses this very issue. And I can just tell you the research design, and then you'll have to go find it next week to get the punchline. But what some Facebook researchers were able to do is they were able to look at the universe of all articles that are shared on Facebook, also the universe of all articles that are shared by your friends. They looked at each of these people individually, so their friendship network and what articles they were shared. And then of those, which articles the algorithm picked to show you at the top of the news feed, and then of those, the articles that you clicked on. And so that gives you an estimate of how much of this sort of sorting process takes place because of the friends you choose, because of the effect of the algorithm, and because of the tendency for you to only read articles that are self-confirming. I'm not going to tell you about the results of that study, but I will tell you that in other studies, the effects of what you click on are very strong, and the effects of what friends you choose are very strong for winnowing down the information that you actually end up consuming. there tends to be a lot of this confirmatory bias. And we haven't published this, but when we've looked at the correlations online in ideology, they appear to be getting stronger over time. But that could also be because of the Facebook platform, which is apropos of another thing we saw earlier today, the Lazar et al. Piece on Google food trends. You know, that worked well for 2 or 3 years, and then the ecology changed, and it was the wrong words that were predicting the flu, and they needed to tune it, but they didn't tune it, and all of a sudden it was making really bad predictions. It could be that the reason why we're seeing this strengthening isn't because we're getting more polarized, it's because the Facebook algorithm has changed over that same period of time. So I don't know, but it's really important. The question you ask is really, really important, and I always had this debate with Cameron Marlowe. As a Facebook employee, it's not surprising that he took the point of view that actually Facebook makes the world better because it brings us more into contact with people who are not like us. And that's definitely true. I spend more time learning about the daily lives of people that are my weak ties now, you know, birthdays and weddings and celebrations and jogs of people that I don't know that well. And as a consequence, it does bring me into contact with a wider group of people. But it also gives me the capacity to focus in on those people who are just as crazy as I am in exactly the same way. And I noticed myself, and this is just anecdotal, but I noticed myself, I have to go, I think, outside of Facebook to get real diversity in what I read. And I'm lazy like everybody else. I don't do that often. I don't watch the news that doesn't align with my political ideology. I won't tell you which one it is. It's probably not hard to guess. It's an open question whether or not more weak context or stronger close context is going to win the day in terms of what drives us either to be more polarized or less polarized. Great.
We're out of time for questions.
Thank you.
But we. I had this vision of Facebook running the voting experiment, but just on Democrats, so that just their votes went up. There's an ethics, yeah. Anyways, thank you all. This has been a really wonderful day full of lots of talks that spoke to each other and challenged us, and James's ending was wonderful in terms of the kind of brave new world we're facing, where big data and the footprints that we began the day with are both creating new questions and then new challenges for how that data influences our life in ways that we're only slowly becoming aware of. And I think this idea of data kind of contributing to our consciousness and our consciousness then contributing to the kind of data we're producing is a really interesting feedback mechanism to consider. So our reception begins right now, right outside, so please join us. Thank you.